All right, Kate, so sorry if this video is really choppy. This is definitely not a perfect setup, but I wanted to kind of start and talk to you and review just a little bit about your periodic table. So first of all, hopefully this will pop up here. On your periodic table, we've talked about how you know how many valence electrons there are. So it's by the column number. Okay, so everything in this column has 1 valence electron. This all has 2, 3, 4, 5, 6, 7, and 8. Okay, and as your notes kind of talk to you about, the idea is that every atom, their goal is to have a full outer shell. So like these guys right here never bond with anything else because they already have 8 full electrons. Or in helium's case, since it's only got 1 layer, and the max it can hold is 2, it's got a full shell. So you never see these elements chemically combining with someone else. But again, the ultimate goal and the reason that elements combine or chemically bond is because they want to get to 8. Whether that means that they would, like let's say nitrogen, for example, could gain 3 electrons, or lithium could lose an electron and go down a layer. So I mentioned to you that they'll do whatever is easiest. So for example, 1, 2, and 3, it's easier to lose 3 electrons than gain 5. And then in the vice versa, it's easier to gain 3 electrons if you're in column 5 than lose 5. So the goal is ultimately to get to 8 for the most part, okay? And that means that they're stable and they've got a full outer shell. So you're gonna wanna make sure you have this in front of you. And one thing I think I drew on your lab or your periodic table is that when these lose an electron, they're like losing a negative, they become a positive 1, right? Because they're losing 1 negative. Everything in column 2 becomes a positive 2 because it's losing 2 electrons. Here, positive 3. This column 4 is kind of goes back and forth, but it can be a plus or a minus. Okay, and then everything over 5, 6, and 7, it's easier to gain electrons, gain negatives. So this one has to gain 3 negatives to get to 8. So this would be -3, -2, -1. Again, 8 doesn't matter because it's full. Okay, so make sure you have something like this to reference in front of you while I'm doing the second part of this kind of thing for you. So let's X this out here real quick. All right. Oops, sorry. Okay, here we go. I'm gonna have tons of them popped up. Okay, so on this lab, we talked about how there is like that 1-to-1 ratio for the most part. Oh well, we'll just talk through this. So for example, this is where you left off, I think, on Mg and F, okay? So if you look at your periodic table, magnesium has a charge of +2 because it's in column 2, so that means that it would have to lose 2 electrons in order to go down a layer, right? And fluorine, if you look at your periodic table, is in column 7, right? Which means it'd have to gain 1 electron, so it would be a -1, okay? So I was doing that crisscrossy thing. Basically, you just look at the charges, you ignore the numbers, but you kind of crisscross them here. So I know that I'm gonna have to have 1 Mg for every 2 fluorines, okay? So in your drawing, you should have magnesium with its 2 electrons, and you should have fluorine with its 7 electrons. And what I like to do is put an X where the open spot is, and you can see that that doesn't work because it's got 2 to give and only 1 to take. So you're going to need another fluorine looking just the same way. Okay, so magnesium would give to each of them, okay? Now, one thing that I didn't show you, and you can kind of reference like question number 1 to look at it, this is like the first part of the assignment, or like the first part of each of these questions. The second part comes when you kind of write the final way it looks. So essentially, if you can remember this here, now you're going to take a second part and you're going to use like brackets. I'm going to erase all this really quickly. Okay, so you have 1 magnesium and 2 fluorine, and we're only caring about like the layer that it like the outermost layer. Okay, so you do these bracket things around each one of them, right? That shows that they are ions now. Okay, magnesium gave its 2 electrons away, so it went down a shell. So its original outer shell is empty, but it's got a charge of +2. Okay, and then fluorine you would show with a full outer shell because it just gained its 1 each, right? So there's 8 around this thing, and you'd put a -1 and a -1. That's what it should look like at the end. You'd have 2 parts, the part with like the lines and dots and arrows, and then the part that looks like this. Okay, so I won't go through the whole thing again, but I will just review with you how you find the charges on number 7. Okay, so find lithium on your periodic table, and it should be in column 1. So that means it's going to get rid of 1 electron, so it's a +1. Sulfur is in column 6, so that means it's got to take on 2 electrons, and it's got a charge of -2. Okay, so if you crisscross them, this would be 2 lithiums for every 1 sulfur. Okay, and then you can draw that accordingly. Hope that helps.